All right, so let's draw a quick line or Cartesian plane here. Okay, so I've got a Cartesian plane. This is my y-axis and this is my x-axis. And I am positioned, this is 0, I am positioned, let's say, at -4 and -3 over here. And I travel on the vector from here to this point over here, which is 1, 2, 3, 4, 5, 6, and 1. And so that vector there will be 6 and 1. I mean, that coordinate will be 6 and 1. And this coordinate will be -4 and -3, putting x first and y. This over here is a vector, and we can work out the magnitude using Pythagoras. And the magnitude will be the length of this entire line. And to find the length of the entire line, I can basically form a right angle triangle and use the right angle triangle Pythagoras theorem, basics, fundamental A, B, C. And I know I can see this length over here is 4 plus 6. So this length at the bottom is 10. And this length over here is, until there, I've moved 3 parts up and 1 part of 4. So this whole length is 4. So C, which is equal to my magnitude of my vector, is given by Pythagoras theorem. And that's going to be 10 squared plus 4 squared, which is 100, plus 16, which is 116, square root of 116. That's going to be my vector. We can write the magnitude of this in different ways. So I've got A, B, and I can say the magnitude using 2 lines like this is equal to the square root of 116, where if we have anything like this, it implies magnitude. We can also, now that we know the x and y components, we can see this is starting x in the positive space because it's going right, and this is y positive because it's going up, starting from A to B. So we can write vector AB with an arrow at the top is equal to a column vector where we put x first and then y. Because I'm starting at A and I finish at B, I put x first and I put y. So x is going to be the motion from A to B. I moved on an x of 10. So it's positive 10. And then at this point, I go y 6. So I got 10, 6. And that would be my column vector. My column vector would be 10, 6. If I rewrite this vector, moving in the opposite direction, and I change this entire vector to go, let's say, hypothetically this way, then I would have gone down and left. And if I go down and left, then vector BA will equal -4 until this point, and then -10 to A. And that would be the translation of this vector from B to A. So A and B to A is actually different. And so they have direction, and the direction changes the sign. And if I have a sign like this, okay, this, I don't know where I got 6 from. This is supposed to be 4. So this I can see is the same as -410, which is the same because I can remove the negative out, which is the same as the negative of vector AB. So that means vector BA is equal to the negative of vector AB by notation. Now, if I have this vector AB and I redraw it, let's say over here below, I'm going to draw another vector line here. Now the Cartesian plane and another vector. So I have vector AB over here. Starts from A and it goes to B, but I call this vector A like this. Right?
Okay.
And I'm replacing the entire vector with a small letter A. If I take that vector and I go in the opposite direction, then the one in the opposite direction will be negative A. And another thing I notice is that if I take this vector and I copy the whole thing, and I redraw it, basically, if I redraw it with the same size but in a different position, it has the same magnitude and the same direction, so it's still vector A. If I draw it over here, it doesn't matter. It's still vector A. So I can move this vector wherever I want. If it stays parallel to the original vector and it is the same magnitude, A, then it's the same vector. So I can move a vector around. But if I take the vector and I maybe draw exactly half of it, starting from here, I go right till halfway, then this vector will be half of A. And if I move that around, it will stay half of A as well. And if I go shorter than that, all the way till here, it'll become a quarter A, etc. And if I go in the opposite direction and I keep it parallel, it'll be negative a quarter A because it's going in the opposite direction. If I go in the opposite direction here, it was negative A. So if I go halfway, it'll be negative half A, and etc. Negative quarter A. And all of them will be A because they parallel. But some of them are half the magnitude of the original, quarter magnitude of the original, or direction of the original. So you can have basically versions, the original vector A, you can have half of it. You can have vectors that go in the opposite direction, which will be negative A. And then you can have half or plus of that. And that will be just vector A for that one. All right, so just a bit of like notation on vectors. And let's suppose I have a situation below, which I've just scrolled down. So let's say I draw another Cartesian plane. I've got an X and a Y. And I've got a vector that goes from here and from there to there. And then I got one more that goes from the start over there, which is my resultant vector. So I've got three vectors going here. Let's suppose this is vector A, this is vector B, this is my y-axis, this is my x-axis. And I want to know what is this vector on the left. So vector A, to travel from the starting point here, I travel along A. Then I go all the way to B, which means that my resultant vector is going to be A plus B. So now this vector becomes A plus B. If I draw this vector anyway, exactly in parallel, it'll be A plus B. I can even draw it here. If it's exactly the same size and parallel, it'll be A plus B. And let's say hypothetically I draw a line that goes halfway through here, so that this is 1 and this is 1 in ratio. So that's equal to that. If that's equal to that, then from this point to this point, that's going to be technically half the vector, which means that vector will be half of A plus B. So I've summed the vectors where I'm saying vector A plus vector B is equal to vector A plus vector B combined. And now I'm halving it. And I want to travel in this direction, then this is going to be negative half a plus b. All right, so just a little bit of factor notation or refresher on that. Okay, here's a question. The question says, I've got p, q, and this is a vector, and this vector is called a. And then from here, I've got capital R, then I've got another vector, which is going this way, and this one is known as b. Okay, and I've got S, which is a point here. This takes me to R. And from P, I draw one line all the way till the central point M, calling it M. So that's B. And these two vectors, this one is A and that one is B. So there's no parallel vectors here. Okay, but maybe looks like PS is parallel to QR. The question says PQRS is a quadrilateral. And this is what's given to us. The information, PQRS is a quadrilateral. We can see that it's 4 sides, right? Is a quad. And it says M is the midpoint. As we suspected, they normally use M as a midpoint. M is the midpoint of RS. Now PQ is given as well as A. We can see that PS is given, and it's from P to S, is given as B. And they're also telling us that PM is a quarter of 2 A's plus 5 B's. So if we double this vector and we double that vector and we add it up and we quarter it, that's going to be PM. So they're saying this is a quarter 2A plus 5B. Okay. Now, find an expression in terms of A and B for SM is the first question. Question number 1 says, find an expression of SM or for SM in terms of A and B. So from S to M specifically, because it's not MS, it's SM. So it's this little vector here. Okay, in terms of A and B. All right. So if I'm traveling from S to M, I have a starting point S and a finishing point M. And I have to travel in that motion. So the way to solve this is to find the alternative route, the known route. So to get there, I would go back this way to P, and then I would go back this way to M. So in other words, I would say the vector SM can be found by traveling SP and then PM, adding the two together. And the resultant vector will be the same. But now SP goes in the opposite direction of B, so it'll be negative B, and PM goes in the same direction, so it's simply the repeated version of 2A plus 5B. And we, at this point, use this as an algebra, like terms and expanding brackets scenario. So we've got 2A over 4, which will become A over 2, multiplying it into the bracket twice. This will become 5B over 4.
So we get A over 2 plus 1 over 4.
And so we want to simplify that, yeah. So 5B over 4 minus B is the same as 5B over 4 minus 4B over 4B. Well, multiplied by 4. And then that'll become B over 4. So that's those two like terms will become B over 4 plus A over 2. And so that will be this vector over here, B over 4 plus A over 2. Do we want to yeah, we can make it nicer.
Like this.
We can even remove like a
Yeah,
number.
it's got 4b plus
Yeah,
2a.
b plus. Um, yeah, so actually 4 times what will give you a over 2. So we have to remove 2. What happens if we remove 2? Take out 2, we will have to b over 2 plus a. Because 2 times that will be b over 4. No, that's going to be 2 over 8 plus a. No, we can't. We have to take out a 1 over 4. And we'll have to b plus 2a. There we go.
Yeah.
Okay. Because a quarter b there, quarter, half of a quarter. 2 times quarters is a half. Done. So that's question 1. Question 2 says, find an expression of QR. So now in question 2, I'm going to write it over here. We got question 2. We want to find QR.
Is QR just, is it a
So QR,
coefficient?
yeah. So
It's a quadrilateral, is it?
QR is
Just
that line there. Yeah. So how do we go from Q to R? We can go back this way, and we can go front against this way. So we're going negative a plus this. So QR is basically QP plus PM. And then we got one more part, this part here.
Yeah.
And that part's the same as this part here because those vectors are equal. So this is going to be b over 4 plus a over 2, which we simplified to a quarter b plus 2a. So that's a quarter b plus 2a because we were told that m is the midpoint of rs. And so we have to add mr in a as well. So to travel this way, we're saying this is the route we're taking. We go there, then we go there, then we go there, and then we reach R. Done. Okay. All right, now we need to write this down and simplify. So we're going negative a plus a quarter of 2a plus 5b, traveling this route. Now we're traveling up this route. Now we're going to travel here, plus a quarter of b plus 2a. Now, negative a, 2a over quarter is a over 2, plus 5b over 4, plus a quarter b, plus a over 2. Now we're going to simplify this now. A over 2 plus a over 2 is a. And a minus a looks like it disappears. 5 over 4 plus 1 over 4 is 6 over 4b. And so this is going to be 6 over 4b, which is 3 over 2b. And so this would be 3 over 2b. That's my answer for question 2. And then question 3 says, describe the quadrilateral PQRS justifying your answer. Describe the quadrilateral PQRS justifying your answer. Well, we can definitely see that because this has a b in it and this has a b in it, those two have to be parallel, right?
Parallel. But they're different magnitudes.
Yeah. So which means that when you have two parallel sides and two unparalleled sides, then we're dealing with a trapezium. So therefore, in question 3, what can we notice about this? It is a trapezium. Because by definition, a trapezium, even if it looks like this, has two parallel sides and two sides that are not parallel. Even though this is not going like that, looking like a trapezium is going like that, it's still a trapezium. All right.